Here we go. We have a question, level order traversal. So you have given a root of a binary tree with n nodes. The task is to find its level order traversal. Level order traversal means BFS. So we have given this tree and its level order traversal is this. So we need to return in a 2D list format. Let's look at the second example. So in the first level we have only 10, in the second level we have 20, 30, in the third level we have 40 and 50. We have first, in this example, in the first level we have 1, then we have 3, 2, then we have 4, then we have 6, 5. So now let's build the approach. So for the level to traversal or BFS, we will use Q data structure. So in the first, so we have only given the root, so we need to insert root. So I have inserted root. So this is node 10, this is a node. We have a Q data structure and it contains node as a data type. Then while Q is not empty, we will run a while loop while our Q is not empty. So our queue contains the nodes in the current level. So in the current level we only have 10. So first step 1, so let me write it here. Step 1 is to pop node and also add. In the next step, or we can write it like this. In step 1 we first need to find the size of a queue. Find size of queue. Then in step 2 run a for loop till its size. Then in the third step we will pop and add. Then in the fourth step we will add its neighbor into the queue. Add neighbors. So first of all, we need to find the size. Our size is 1, so we will run a for loop till 1, only once. So then we will pop out and add it. So I have added. Then add its neighbor. Its neighbor is 20 and 30. 10 has neighbors. Its neighbor are 20 and 30. So insert that. That's it. We only need to run once. Then again our queue is not empty, so we will again follow these 4 steps. In the first step we will pop out. In the first step we need to find its size. So we have 2 elements. We will run a for loop 2 times. We will pop out and add. Then add its neighbors. Its neighbors are 40 and 50. So again we find the size. We run a loop only for once, but we have a size of 2 initially, and we have run a for loop only once. So this is the second time that we are running our for loop. So in this turn we will remove 30, add 30 and add its neighbors. Its neighbors are null and null. That's it. So we have run our for loop twice and we have fulfilled this step 2 and 2, 3 and 4. Again Find the size. Our queue is still not empty. Find its size. Its size is 2. Size is 2. Then run a for loop twice. I have run only once. Remove, add, add its neighbor. Its neighbor are null and null. Run the second time. Remove, add, add its neighbors. Its neighbor are null and null. So we have run our for loop twice. Then again we will check, is our queue empty? Yes. At this stage our queue is empty. So that's it. This is our answer. This is our answer. Let me do the same for this. So these 4 steps will run while our queue is not empty. In the first step, what we need to do? We need to insert the root node. So I have inserted the root node. Then we will run this loop. Our queue is not empty. No. We have one number of element. Then iterate only once. Remove it. So remove it. Add it. I have added it. Add its neighbor. I have added its neighbor. So I have fulfilled this thing because initially our queue contains 1. So we have run our loop only once. Then still our queue is not empty. Size is 2. So we will run our for loop 2 times. Remove 3. Add 3. Add 3's neighbor. 3's neighbor are null and null. That's it. Run the second time. In the second iteration, add and add its neighbor. Its neighbor is only 4. That's it. We have run twice. Still our queue is not empty. We have a size of 1. Run only once. Remove it. I think the value here is 2, not 4. So remove it, add its neighbors. Its neighbor are 6 and 5. 6, then 5. That's it. We need to run only once. In this, still our queue is not empty. We will run our for loop twice. Remove it. I have removed it. Add it. I have added 6. Add its neighbor. Its neighbors are null and null. Remove the second node because we have 2 nodes. Add it. Add its neighbors. Neighbors are null and null. This is our answer. So that's how it will work. You can verify it. In the first level we have 1. Second level we have 3, 2. Third level we have 4. In the fourth level we have 6, 5. So that's how it will work. Let's code this. So we need to return 2D array list. So first of all create that. Then we also need queue, data type node, queue dot add root while our queue is not empty. Find the size. Iterate till size. Remove a node. For this level, we will need to create a array list. Let's say level new array list. Then add it, but we need to add integer, not node. So we will add level dot add pop dot data. We need to insert the integer, not the node itself. That's it. While if pop dot left is not null, add its neighbor. This is for the next level. While right is not null, add right. So we have built current level list. So add this list into your answer and return the answer. Let's run this and check if there is any error. So let's submit this. Let's talk about time and space complexity. So we have a queue, we have answer. So time complexities, we are iterating a node only once. So time complexity is order of n, and the space complexity. In the worst case, let's say our queue contains in the answer we have order of n nodes in the answer, and in the queue we have level number of nodes on the worst case. So let's say, yeah, so it will be order of level number of nodes, we can say. So let's find out. So we have met the expected time and space complexity. Thank you all for watching this video.